Welcome back to the Deep Dive. Today we are looking at something that, on the surface, looks like a standard IT ticket moving some files around.
Right.
But when you actually peel back the layers, it reads more like a directive from a spy thriller. We're analyzing a concept called pristine state migration.
It definitely has a Mission Impossible ring to it.
It really does. The
Yeah.
whole vibe is get in, secure the asset, move it to a safe house, and then, poof, vanish without a trace.
Mm-hmm.
But we aren't talking about international espionage here. We're talking about a specific lab scenario from the Red Hat Certified System Administrator series, specifically Season 2, Episode 28.
Right. And while the spy framing is, fun,
Yeah.
the source material here is actually a rigorous guide on system hygiene. It's a lab designed to prep admins for the exam, sure.
Yeah.
But the philosophy behind it goes way beyond just passing a test.
Yeah.
It's about the discipline of system administration.
That's what jumped out at me. This isn't just type these 3 commands to copy a file.
Yeah.
It feels like a lesson in mindset. The mission is to migrate sensitive data from a legacy user to a new service account. Lock it down so tight that nobody else can see it, and then clean up so thoroughly that no one knew you were ever there.
Exactly. We're going to cover dependency management, archiving, symlinks, and what I call the zero trace policy.
Okay.
These map to specific exam objectives 1.6, 1.9, 1.10, and 9.1. But for you, the listener, this is really about professional standards. It's the difference between a messy admin who leaves configuration files scattered everywhere and a professional who maintains the absolute integrity of the server.
So let's get into the weeds. The lab starts with what I'm calling the pre-flight check. And honestly, the very first command in the source material stopped me in my tracks because it uses some logic I don't see every day.
Oh, yeah.
It says rpm-q tar dnf install day I.
The double pipe. It's a classic, but often misunderstood by people new to shell scripting.
So break that down for us. I know dnf install gets the software and car is the archiving tool, but what is the logic happening with rpm-q, those vertical lines? It looks a bit like a math equation.
It's a conditional execution, and it's actually a beautiful piece of scripting logic because it's lazy in the best possible way.
Lazy.
The double pipe, here, represents a logical or in the shell.
Or, as in this or that.
Precisely. The system looks at the first command, rpm-q tar. It's querying the RPM database to ask, is the package tar already installed?
Okay, simple enough. It checks the inventory.
Right. Now, if that command succeeds, meaning tar is already there, the system just stops. The or statement is satisfied.
It says, okay, the first part is true, so I don't need to look at the second part.
Exactly. It doesn't even attempt to run the installation command.
It just skips it.
Completely. But if that first command fails, meaning tar is missing, then and only then does it cross that double pipe and execute the second command, dnf install the swytar.
That's clever. So it prevents the package manager from spinning up, refreshing repositories, and wasting time if the tool is already there.
Efficiency is definitely part of it. DNF can be slow. But in the context of pristine state migration, this isn't just about saving 10 seconds. It's about intelligence gathering.
Intelligence gathering.
You, as the admin, need to know the state of the battlefield before you engage. You need to know, was tar here when I arrived? Or did I bring it with me? Because that dictates your exit strategy.
Oh, I see where you're going. Because if I brought it with me...
then you have to take it with you when you leave. If it was already there, you must leave it alone. That single line of code is essentially documenting the baseline of the system so you know how to restore it later.
That sets the stakes immediately. You have to be aware of your footprint. Okay, so we have our tools. Next, the lab sets up the actors for this little play. We create a legacy user and a migrator user.
Right.
And then there's this command to create dummy data. Touch home legacy user project alpha beta gamma.log. I always appreciate seeing brace expansion in action.
It is a lifesaver for rapid prototyping.
For sure. Instead of typing out project alpha.log, project beta.log, you just put the differences in the curly braces and the shell expands it.
Right. It creates 3 files instantly.
Yeah.
It seems minor, and I know some people think, I can type fast, why bother? But it demonstrates fluency with the shell. In a timed exam like the rhcsa, or during a critical outage where your boss is breathing down your neck, saving those keystrokes and avoiding typos matters.
So the stage is set. We have legacy user holding the data project logs, alpha, beta, and gamma. We have a migrator user. This is our service account who needs them. Now we move to step 2, the core task.
The migration itself.
We need to move these logs to a temporary staging area. But we aren't just copying them, right? The source material is specific.
No, the objective here is archiving. We aren't moving loose files. We need to bundle them up into a single manageable unit.
The command is tar-cvzf tmp migration data.tar.gz home legacy user. Now, tar flags can feel like alphabet soup.
They really can.
You've got C, V, Z, and F all mashed together. I feel like a lot of people just memorize XVF to extract and CVF to create, but let's decode CVZF for everyone.
You never want to just mash keys with tar. You need to be precise because the order sometimes matters. C stands for create. We are making a new archive. That's the action.
Okay, C for create.
Z invokes gzip. This applies compression. That's why we use the .tar.gz extension. It's taking that bundle of files and, squeezing the air out of them to save disk space.
It becomes a compressed tarball.
Exactly. Then F stands for file name. This is the one you have to be careful with. It tells the command, the very next string of text I type is the name of the file I want to create.
So if I messed up the order and put F before Z...
Tar would try to create a file named Z. It gets messy. You usually want F to be the last flag right before the file name.
And then there's V. The source material emphasizes this.
V is for verbose. This is critical in a lab or during a complex migration. It forces tar to list every single file it processes on the screen as it's doing it.
So it's visual confirmation. Adding Project Alpha, adding Project Beta.
Exactly. Without V, tar is silent. You hit enter, the cursor blinks for a second, and then you get the prompt back. You hope it worked. You hope it grabbed the right folder. With V, you verify.
Trust but verify. Now, I want to ask about the destination. We're putting this archive in Champ. Why not just move it straight to the migrator user's home directory? Why the stopover?
A few reasons. First, in a real-world scenario, you might be moving data across file systems or different physical drives. Temp acts as a neutral ground, a demilitarized zone, if you will.
A DMZ for data. I like that.
Exactly. It satisfies the archiving objective, but it also strips away some of the complexity of permission inheritance until we're ready to assign it. If we moved it directly, we might accidentally overwrite something or inherit permissions we didn't intend. Putting it in template lets us inspect the package before delivering it.
That makes sense. It's a staging ground. But now we have a security issue. We created this file as root, so root owns it.
Right.
The migrator user can't touch it yet.
Correct. Root owns it, and depending on the system defaults, others might be able to read it. So the next step is the handoff. We run chown migrator.migrator tmp migration data.tar.gz. We are explicitly stating this data now belongs to the service account.
But ownership isn't enough. The source material highlights the next command as a critical security step. We have to run chmod 600.
This is Objective 1.10, Securing Archives. This is non-negotiable.
600. Why is that the magic number? Why not just leave it at the default, which is usually 644? I feel like I see 644 everywhere.
Let's look at the octal notation. It's 3 digits. The first digit is the owner, the second is the group, and the third is everyone else. A 6 equates to read and write access.
Okay, 4 for read, 2 for write, 4 plus 2 is 6.
Exactly. So 600 means the owner has read and write access, the group. 0. Everyone else, 0.
And if we left it at 644?
Then the owner has read-write, but the group has read access, and everyone else has read access. That means any user on the system, maybe a compromised account or just a nosy employee, could copy that archive, open it up, and read your sensitive logs.
So 600 is essentially a sealed briefcase handcuffed to the courier's wrist.
Precisely. In an exam, 644 is a fail. In the real world, it's a data breach. You have to apply the principle of least privilege. Only the person who needs to see it gets to see it.
Okay, briefcase secured. Now here is where the lab gets really interesting regarding system architecture. We have the file in temp. The migrator owns it. But the lab requirements say the data needs to be accessible from the migrator's home directory.
Right. The user expects to see their data in their home folder.
Instead of moving the massive file, the guide tells us to use a symlink. The command is lnstymp migration data.tar.gz home migrator latest migration.
This covers Objective 1.9.
I usually think of symlinks like desktop shortcuts in Windows. Is that a fair comparison?
It's a perfect comparison. The file doesn't physically live in the home directory. The home directory just contains a tiny pointer, a signpost that says, hey, if you're looking for latest migration, go look in temp.
Why is this better than just moving the file? Why complicate it with a link?
Think about scale. In this lab, the files are tiny text logs. But in production, that archive could be a 500 gigabyte database dump.
Right, okay. That changes things.
You might not have 500 gigabytes of space in the home partition. Home is often on a smaller, faster drive for user configs, But TP or a dedicated var partition might be massive, cheap storage.
Ah,
By using a symlink, you keep the user's home directory lightweight and fast, while still giving them instant access to the heavy data stored on the larger drive.
it separates the data storage from the data access. That's smart.
It also allows for version control. Today, the link latest migration points to backup January. Tomorrow, you perform a new backup called backup February. You just change the link. The user scripts don't need to change.
So it abstracts the back-end details from the user.
Exactly.
So we've checked dependencies, archived the data, locked it down with 600, and linked it. Most people would call it a day here. Job done, ticket closed.
Most people would be wrong. And in the exam, that attitude fails you. A professional admin never assumes a command worked just because the terminal didn't throw an error code.
This brings us to step 3, the verification sequence. The source material is very specific. We have to prove it works. The first check is LSU-SESL on the link to make sure the arrow points to the right place. But the second check is the one that really caught my eye. Sudo su migrator tar-tvf homogrator latest migration.
This is the ultimate functional test.
Why the sudo su migrator part? We are already root. Root can do anything. Why bother switching users just to run a listing command?
That is exactly why we switch. Root ignores permissions. Root is a god on the system. If you test access as root, it will always work, even if you messed up the permissions and set them to 0.
So it's a false positive.
It's testing in a vacuum. By using sudo your migrator, you are impersonating the user, you are seeing the file system through their eyes, you are testing if the permissions you set actually allow that specific user to read the file.
That's a great point. Testing as root is basically cheating.
It proves nothing. You have to verify the constraints.
And we use the T flag in tar again here, tar-tvf.
Yes, T for list. We aren't extracting the files. We don't want to clutter the directory. We're just reading the table of contents. If the permissions are wrong or if the archive is corrupted, this command will fail.
So if I set the permissions to 600, but owned by the wrong user,
Permission denied.
if the link points to a non-existent file,
No such file or directory.
but if it lists projectile alpha, beta, gamma,
Then you know. The link works, the user has access, and the data is intact. Verification complete.
now the getaway. Step 4, the zero trace policy. The LOB guide says we need to remove the user's legacy user and migrator with userdel evi-r.
And that evi-r is vital. It stands for recursive or remove home. If you forget it, you delete the account, but you leave the home directories behind as orphan folders.
And that's just littering.
Over time, that becomes digital clutter that fills up your disk and confuses the next admin. Who owns this folder? Can I delete it? You don't want to leave those questions behind.
Clean sweep. We also delete the staging file and tmap. But then we circle back to the beginning. That first command with a double pipe, the cleanup step says, DNF remove DSAR.
And this is where you have to pause. This is where you have to remember what you did 5 minutes ago.
The guide has a massive warning here. It says, only run this if tar was not present during the step 1 check.
This is the trap.
Why is this such a big deal? If I accidentally delete tar, isn't it just a standard tool? Can't I just reinstall it later if I need it?
In a lab, sure, who cares? But in a production environment, you might have just caused a catastrophic failure. Tar isn't just a tool for you, it's a utility used by the system itself.
Like what?
Imagine there are automated backup scripts running every night at 3 a.m. What do they usually use to bundle logs? Tar. Imagine log rotation scripts or even deployment pipelines that unpack code.
If I delete the tool.
You break every single process that depends on it. You might not notice until the next morning when the backups fail or the logs fill up the disk and crash the server.
All because I was trying to be clean and remove what I thought was my tool.
Exactly. This brings us back to the pristine state philosophy. The goal is to leave the ecosystem exactly as you found it. If tar was part of the ecosystem when you arrived, it must remain there. If you installed it solely for this mission, you remove it.
That connects so perfectly to that first RPMQ command.
Yeah.
You weren't just saving time, you were documenting the baseline.
Intelligence gathering ensures you don't invoke the law of unintended consequences.
It's a powerful lesson. Administration isn't just about executing the current task. It's about maintaining the long-term stability of the environment.
That is the definition of a senior system administrator. A junior admin does the task. A senior admin understands the impact of the task.
So, to recap our heist, we used conditional logic to check our tools and establish a baseline. We archived data to a neutral zone using verbose mode to watch it happen. We secured it with Shaman 600, that handcuffed briefcase. We used symlinks to decouple storage from access. We verified everything by impersonating the user, not just checking his root. And finally, we cleaned up, strictly adhering to the baseline we established at the start.
A perfect execution.
I love it. Now, here is a thought for the listener to take with them. We talked about the danger of removing a tool like tar if it was already there. But flip that around. What if you install a tool, say, a specific version of Python or a compiler to get your job done, and you forget to remove it?
Shadow dependencies. That is a nightmare scenario.
Right. 6 months later, another admin sees that tool, assumes it's part of the standard build, and writes a critical application that relies on it.
Mm-hmm.
Then you come back for a generic cleanup, realize you left your trash behind, and delete it.
And you just crashed the new application because you left a footprint, someone stepped in it and built a house on it.
It really highlights why zero trace isn't just for spies or exams. It's for survival in a shared environment.
Absolutely. Every change you make to a server tells a story. You want to make sure you aren't writing a tragedy.
That's a great way to put it. Thank you so much for breaking down this pristine state migration with us. It's amazing how much depth is hidden in a single lab scenario.
My pleasure. It's always fun to dig into the why behind the commands.
And thank you for listening to The Deep Dive. Check your permissions, verify your links, and remember, leave no trace. We'll see you on the next one.